Alright, here we go. Let's insert a ramp here. Here we go. We're going to put a ramp. Let's do not a ramp, but a box. Alright? You have a lot of boxes in physics. Okay, this box right here has all the forces that you need to know. It has applied force. We'll call that the applied force going this way. It has a friction force. Alright? It has a normal force. And mg means what? Weight. Means weight. So now that it has a frictional force, how are we going to find that? Well, let's say this box, since these arrows are equal, let's say it's moving at constant velocity. The reason why we say constant velocity is because this applied force here is just as big as the friction force. So that's easy. Well, if my applied force is moving in one direction, and it's in magnitude, which means the size, the number, is equal to my friction force, then I can find what that is by multiplying a coefficient of friction, okay, and if it was kinetic or static you would say S times your normal force. Well, what's your normal force equal to? Well, your normal force and your weight are the same. Okay? Because look, it's not going up. It's not going up in the air. It's staying on the ground. So the normal force and the weight are the same. Okay? What about it sliding? That's static is just to get it started. So static equals to start it. Start it. So what if it were sliding? If it were sliding friction, that would mean kinetic. So you do it the same way. Since it's going at constant velocity, your applied force, this one, is the same as your frictional force. And that means your coefficient of kinetic friction, that's a U by the way, a little Greek U, times your normal force. Well, shoot. Well, what if you didn't know your coefficient of friction? Well, we can find that out actually. If our actual applied force here is equal to our friction force, then your friction force divided by your normal force, which is equal to what? The weight, will be able to find our little mu, our little coefficient of friction. What a coefficient of friction, folks, is it's the how much friction basically you're going to experience between the floor and the box. Okay? So that's if the box were on the ground and moving at constant velocity. We can find coefficient of frictions, we can find the friction force, okay, just by doing our little diagram here. All kinds of stuff.